Hello friends, welcome back to my YouTube channel. So in the last class we have discussed about what are natural numbers, whole numbers and rational numbers, irrational numbers as well as real numbers. But rational and irrational numbers are very important. So we have a chart here. You can see that. Let us quickly glance. So rational numbers are always terminating, as I told, like 0.5. 0.6 or 0.61 something, it is terminated. So these are rational numbers. If it is non-terminating, then also it is rational number, but the thing is that the numbers should be repeated, like 0.3, 0.333, this is repeated. Or if you consider 0.41, 41, 41, dot, if it is repeated, like 41 is repeated, 41 is repeated, or else we can consider example 0.519, 519, like this, dot, 519 is repeated, so this is also a rational number. But that non-terminating numbers are irrational numbers. Non-terminating, non-recurring, this is very important. Non-terminating, here you can see the example 1.414, dot. If we have something like here 2, suppose 4142, it is not repeating here. If you consider 4142, these two numbers are different, so this is non-terminating as well as non-repeating. Now let us quickly look into some of the problems. I have taken some few examples regarding how to identify rational and irrational numbers. Once we'll take this first problem, that is root 23. Can you guys tell me, like, root 23, is it a rational or irrational number? Of course it is an irrational number. It is an irrational number. Why? Because root 23 is not a perfect square. Root 23 is not a perfect square. We cannot further solve this one, right? So this is an irrational number. Like now tell me that, like, whether root 225 is a perfect square. Is a perfect square? Yes, it is a perfect square. It is a square of 15. 15 square we will get 225. So we will get the answer 15, right? Square root of 225 is 15. That's why this is a rational number. This is a rational number. Third one, we can look into third one, 0.3796. This is terminated. Remember guys, this is terminated. Always terminated decimal will be a rational number. I have just now told that always terminated decimal is a rational number. If it is non-terminated, then it should repeat. That's it for rational. Let us look into fourth example, 7.478, 478, dot. This is non-terminated, but we also need to look into whether it is repeating or not. See here, 478 is repeating, 478 is repeating, and further it will repeat 478. So this is a rational number because here it is repeating. Let us take an example of fifth question. Just pause the video and check that whether it is a rational or irrational number. Let me know in the below comments. Here I will be going to consider, I will solve this one. So here what we are getting, this is anyway non-terminated, this keeps on going. So here we have 10, here we have 100, here we have 1000, 10,000, like that. So this is not repeating, right? If this was like this, 1.101010, dot, if this was like this, then it would be a rational number because it is repeating, but this is not repeating here, so this is an irrational number. Let's go to next question. this we can anyway tell that this is a terminating, so obviously this is a rational number, because here 5.876 is a termination, it is terminated. Now let us look into 7th problem. Root 10, is it a perfect square? This is obviously not a perfect square, so this is also a irrational number. Root 3, is not a perfect square, this is also a irrational number. What if you consider root 64? Root 64 is a perfect square. The square of root 64 is 8. 8 8 is 64, right? So this would be a rational number. Like that we can identify. Here see the next example, 8th. Root 49 is there. What is root 49? We know that 7 square is 49. 7 7 is 49. So 7 is a perfect square. So this is a rational number. This is a rational number. I would like to leave you guys to comment out this 9th one. Let me know in the comment section whether it is a rational or irrational number. Whether it is a rational or irrational number, let me know in the comment section below. So let us see the 10th. This is somewhat interesting, right? Nothing. This is simple. It is in the form of a b plus b into a minus b, a plus b into a minus b. We know the formula, right? A square minus b square. We know the formula, a square minus b square is equal to a plus b into a minus b. Just substitute that one. A square means here 2, that is 2 square, minus b square means root 3 whole square. Remember guys, first we need to solve the problem, then only we can consider it as rational or irrational number. By seeing this, here if it is a root, you cannot directly say that it is an irrational number. First you need to solve the problem, then only we'll get to know. After solving this problem, we may get rational or irrational number. So here 2 square is 4, minus root and 2 cancel, that is 3. 4 minus 3 is 1. So 1, we got 1 as an answer. So this is a rational number. Let us look into the 11th question, 11th problem. Square root of 0.04. So under root of 0.04. This can be written as 4 divided by, this is 1, this is 0, this is 0. Like this we can write. We know that, okay, let's directly solve. We know that square root of 4 is 2, divided by square root of 100 is 10. 10 10 is 100 and 2 2 is 4. So you can keep this as 2 by 10. It is in the form of p by q. Rational numbers. Anyway, we know that rational numbers for what is the definition of rational number? The numbers which are in the form of p by q, where q should be not equal to 0. We have discussed in the earlier class. So this is in the form of p by q. So this is a rational number. Or you can solve further, like 2 by 10. We can solve 2 1 2 5 are 10. 1 by 5. 1 by 5 is 0 point something, like 0.2. This is a terminated anyway. So this is a rational number, right? Okay, let us solve 12th one. Let me clear out this one. It's getting okay. Let us solve the 12th problem. We have here 7.478 dot. So here we can blindly say that this is a rational number. How? Here it is repeating 478. So if it is repeating, then you can close your eyes and you can mark it as rational number. This is a rational number. This 13th one, this is very simple. you can answer within a fraction of seconds. Pi by pi. What will be the pi by pi value? 1. Pi will cancel 1. So 1 is obviously a rational number. So that's it, guys. Today we have discussed these many problems. These are very small problems. You can easily identify the rational and irrational numbers among the following. You can take few more examples from the internet or somewhere, then you can solve this. Thanks for visiting my channel. If you guys like my video, then please subscribe and click the bell notification icon.